right, today's lesson is on graphing motion. This is lesson 1.12, video notes. In this lesson, you will describe the position and motion of an object using a graph. Just a reminder, when you watch videos in class, you need to make sure you're in a quiet place using headphones or earbuds. Put away anything that is distracting and have your notes ready to go. You can pause the video or replay it at any time. You can also come back and rewatch when you're ready to study for your mastery check. Do you have your video notes? Make sure you have them before getting started. How can we study motion? So position and time can be used and can be compared using a graph.
In this video, you will learn what a distance time graph is and how to use it. Imagine Sam cycles from his house to his cousin's house 10 kilometers away. It takes him 30 minutes. He waits there for 30 minutes before continuing on his way to his sister's house. She lives 6 kilometers away, and he arrives at 3 p.m. He stays for an hour before returning home. He gets back in at 5. What you have just seen is the formation of a distance time graph, documenting Sam's journey. The line A to B shows him traveling away from his house. Because this is a straight line, it shows he is traveling at a constant speed. The flat line B to C shows that his speed is 0. He's not moving. Because speed is found by dividing distance by time, on our graph it's represented by the steepness of the line, also called the gradient. To calculate speed from a graph, we need to measure the gradient. We do this by selecting the 2 points we want to find the gradient between, then finding the change in distance and the change in time. Try and find the change in distance and time for the highlighted line. We can see the change in distance is 10 kilometers, and the change in time is 30 minutes. 30 minutes is the same as 0.5 hours. To find the speed, we divide distance by time. So we divide 10 by 0.5. This gives us a speed of 20 kilometers per hour. Try finding the speed between C and D. The change in distance is 6 kilometers, with a time of 30 minutes or 0.5 hours. 6 divided by 0.5 equals 12 kilometers per hour, so slower than part AB. This tells us that the steeper the gradient at a point on the graph, the faster the speed at the point. The flatter the gradient, the slower the speed, with a completely flat line meaning 0. Where the line is in the negative direction, this shows the direction of travel is opposite, such as back home. Can you work out the speed? The distance change is 16 kilometers, with a time change of 1 hour. So Sam is traveling at 16 kilometers per hour. If a line is curved upwards on a graph, it's showing a change in speed, an acceleration. If the curve is flattening off, this also shows a change in speed, a deceleration. So there you have it. To find speed, using a distance time graph, work out the value of the gradient by dividing the change in distance by the change in time.
All right, let's review what that video is about. That distance time graph that you saw does not show the actual path that an object took. That bicyclist didn't go up a hill straight and then down a hill, okay? It's showing the different speeds, When an object is moving at a constant speed, the line will be straight. We'll talk about curved lines later, but the constant speed, the line will be straight. When we look at the slope of the line, if that is changing, meaning it's either steeper or lower down, that means the speed has changed as well. So if you see a very steep slope, that means that the speed is very fast. But if the slope of the line is very shallow, closer to the time line, then that is a slower speed. Here's another review of all the possible lines you might see on a distance time graph. So if the line is straight, remember that is a steady speed. If the line is curving in any way, that means it is changing speed, meaning it's going to get faster or slower depending on which way the line is curving. Now, if you see, as in the middle here, if we see the line going straight across, very flat line, that means that that object has stopped, meaning time is passing by, but that object is no longer moving up or down, meaning further away or closer. It's staying in one position while time is going by. Thank you so much for watching this video on position time graphs. Be sure to review if you need to and keep your notes with you to study.